These are the Algebra 1 4.5 notes, so let's start with some vocabulary today. All right, so today we're talking about two different things, residuals and a line of best fit. So a residual is the difference of a y value of a data point and the y value found on the line of fit. So like we have this graph right here, this line, and so if you have a data point, so like one off the table we graphed, and it's above the line, then it has a positive residual. This means that the space between the data point and the line, that is this residual, meaning how far off the line it is. If the data point's above the line, it's a positive residual. Now, if the data point is below the line, so like the one you graph from the table and then you draw your line through, and if it's below the line you drew through, that's a negative residual. And if the data point is actually on the line, then it has zero residual. All right, so if the residual is positive, that means the space between the line is positive. It is above the line of fit. If it is negative, then the data point is below the line of fit. And if it is zero, then the data point is on the line of fit. Okay, so we made lines of fits in the previous lesson, but today we're talking about a line of best fit. So the precise line of fit is called the line of best fit, and it's created mathematically. We're going to use technology to do it. And the process we do it on the graphing calculator is called linear regression. Regression is you go backwards. So it's like you're taking your points and you're going backwards to write a line that fits those points. Now, when we do this, the technology or the graphing calculator will give us an R value. The R value is called the correlation coefficient. So when they say, what is the correlation coefficient? We find that on the graphing calculator, and it is the R value. And this correlation coefficient, this number, tells us if the correlation is positive. And if you remember from 4.4, a positive linear correlation means the points are headed in a positive direction, like a positive slope. And then a negative linear correlation isn't bad, it just means they're headed in a negative direction. And so if the correlation is positive, it just tells you the direction of relationship they are. And it also will tell you how closely the equation models the data, so like how good of a model it is or how poor it is. So here's the thing. The R values go from -1 to 1 in every number in between. The closer it is to 1 or to -1, it is a strong correlation. The closer it gets to 0, it is getting weaker. So if the R value is in this range close to 0, so like 0.1 or 0.2 or 0.3 or -0.1 or -0.2, that's not really a good correlation. Okay, 0 means no correlation. Anything close to that is pretty weak. The closer you get to 1, which 1 is perfect correlation, and -1 is also perfect correlation. So if you have like 0.9 or negative 0.8 or something like that, that's really close to 1 or -1, and so that's a very strong correlation. So this R value helps us judge the correlation. Okay, let's find out how to do this. So it gives us this table, and it says the table shows how many teachers and how many students in 6 schools. So it says use technology, so use a graphing calculator to find an equation of the line of best fit. If you're at home doing this and you have an iPhone has an app, Calculate 84, which will look like a graphing calculator and will also do this. All right, so I did also pull up our linear regression sheet that I gave you. It has steps here, and so you can see the first step, step 1, is press stat and then hit enter on one edit. All right, so we're going to do that first. We're going to swap back and forth between these. All right, so the stat button is over here. So remember, I'm going to hit stat, and then I'm going to hit enter where it says one edit. So just hit the enter button. Now my list, you see this is list 1, this is list 2. They already have numbers in it. So how I can deal with that, I can use the up arrow button. See how the black cursor is on L2? And I can hit clear, right here's clear, and then hit enter down at the bottom right. Now use the up arrow and the left arrow to where the black cursor is on L1 and hit clear, enter, and it'll just clear your numbers out. Okay, so let's see here. That's what it told us to do first. Now look at what step 2 says. Step 2 says input the data, press enter after each number. and it says L1 are your X values and L2 are your Y values. Now we're going to use, this is our data right here. And so this is going to be L1 and this is going to be L2. So you're literally going to sit here on your calculator, and in L1, you're putting that first column, you hit 10, enter, 12, enter, 13, enter, and so on. And then you make sure to go in order as what it says. And if you have a typo like I just did, you fix it. And then use your right arrow button and go over to list 2 and type in your Y values there. Hit enter after each one. Go ahead and pause this video and type those data in. Okay, I have all my data typed in. I do a quick check to make sure that I don't have any typos. All right, and then following along with what they told us to do is step 3. We don't really need to adjust our window. We could if we want to see it on our graph. I'm going to go ahead and I'm just going to make the equation first. So I'm going to go ahead and have us jump over here to step 6 to just find your equation. So look what it says. It says press stat, arrow over to calc, and then we're going to enter on 4 linear regressions. Let's try that. So we press stat, we use the right arrow to now we're on calc, and we want this 4th one, linear regression. So you can go down to 4 and hit enter, or you can just press the number 4. Okay, it says X is L1, Y is L2, and go ahead and go down to calculate and hit enter. If yours looks different, it's just an older operating system, you can just hit enter once it pulls up. All right, so A is my slope, it's 20.6. B is my y-intercept, let's just call it 42. So my equation that I'm going to write down is going to be y equals 20.6x plus 42. All right, now it says identify and interpret the correlation coefficient. So my correlation coefficient wasn't turned on. Let me show you how to do that real quick. All right, we're going to go to mode, and then we're going to go down. Yours may not need to go down. Yours may show it all at once. I'm going to stat diagnostics, and it's off. I'm going to scoot over to where the cursor is on. See how it's flashing on, and hit enter. That turned it on. To get out of here, I'm going to do second, and then the mode button. See above mode, it says quit. So second quit. Now let's do that linear regression again to get the R value to pull up. So press stat, go over to calc, and down to the 4th one. I already have my data typed in, so I don't have to do that again right now. All right, look what it shows me. It shows me R squared, which we won't use in this class. It shows me R. R is 0.9595. Okay, so I'm going to call that, that would round to 0.960. We usually do our R value to 3 places. So that's 0.960. So it's positive, and it's very close to 1. And so that means it has a strong, because it's close to 1, and positive, because literally it is positive, correlation. So what that tells me is as the number of teachers increase in these schools, the number of students increase. They're very much correlated. Okay, it wants us to interpret the slope and the y-intercept. The slope was 20.6. And so that means the number of students increase, because y is the number of students, by about, we're just going to call it about 21 for each additional teacher. Here they have a certain amount of class size they have to keep. Okay, and then the y value here, the y-intercept is 42, and it really has no meaning in this case. Okay, because what it would mean is you would have 42 students when you have 0 teachers. And that doesn't make sense because you couldn't have a school, you can't just have 42 students running around without any supervision or instruction. All right, since we now know what to do, we're going to do this one a little bit faster, but you can always pause the video to do what you need to do. So I'm just going to hit clear to get back to a blank screen. So where I went to put in my data is I go stat, and it's on edit. I hit enter on edit. And remember how I clear my data is I go up to where it's on L2 and I hit clear and then the enter on the bottom right. And I go up to where it's the black cursor is on L1 and I hit clear and then enter on the bottom right. Now we're going to pause this video and you're going to type in your data from this example. So this goes in L1, the Y values go in L2. Go ahead and pause the video and type in your data. All right, my data is typed in. I double checked for typos, errors. Now I'm going to press stat. I go to the right arrow to calc, and I want to go down to 4, which is linear regression. So I can hit 4, or I could just go down to 4 and hit enter. Either way. So now I go down to calculate and hit enter. And because I turned on my stat diagnostics, everything I need is right here. So my slope I'm going to call 0.5. My y-intercept I'm going to call 3.6. And my r value, we usually go to 3 places, so 0.973. All right, let's come back and write that down. So my slope was 0.5, and my y-intercept was 3.6, and my r value was about 0.973. So the correlation coefficient is positive, and it's very close to 1, so it is strong positive. And this is x is the number of years after you've like planted a tree or whatever, and y is the height of the tree. And so that makes sense that as time goes on, the height gets taller. All right, and so then interpret the slope. The slope was 0.5, and think of it as 0.5 over 1. So this was, the y value was the height, and this was year. And so it means the height increases, because it's positive, by 0.5 feet per year. On average, it may have better years and worse years, but that's just in general. And then the y-intercept was 3.6. And so that means the tree started at 3.6 feet tall at 0 years, which means when it was planted. So like someone went and bought it and planted it, and that's year 0. Obviously, it didn't begin at 3.6 feet tall. It's when we started gathering data.